the matrix 1, 5, 6, 7 verify that A plus A dash is a symmetric matrix. A is already given to you. Let us work out A dash. And A dash will also be a matrix of order 2 by 2. Write the elements of first row 1, 5 in the first column and second row 6, 7 in the second column. And now what is A plus A dash? Both the matrices being of the order 2 by 2, just add the corresponding elements. You get 1 plus 1 2, 5 and 6 11, 6 and 5 11 and 7 and 7 you get 14. So A plus A dash is 2, 11, 11, 14 the matrix. Now let us we have to, because prove it is symmetric. So to prove this symmetric, what should we prove? That A plus A dash whole dash, that is its transpose of this matrix as a whole, will remain same as the matrix A plus A dash. Call this A plus A dash as 1. And now work out its transpose, that is A plus A dash whole dash. So it will be, take the elements of first row 2, 11 in the first column, 2, 11 the elements of the first row in the first column and that of second row in the second column, call it second. We observe from first and second that the two matrices are same. From first and second we find that both the matrices are same. To conclude that A plus A dash transpose is same as A plus A dash, and hence we can say that A plus A dash is a symmetric matrix. Now, in question 8, we have to prove that now in question 8, second part, we have to prove that for the same matrix, A minus A dash is skew symmetric. So you already have A as 1, 5, 6, 7. We have also worked out in the previous part A dash as 1, 5, 6, 7 written like this, A and A transpose. What is the value of A minus A dash? So first of all you work out A minus A dash. 1 minus 1 0, 5 minus 6 minus 1 and 6 minus 5 1, 7 minus 1, 7 minus 7 0. So you have A minus A dash with you. Now let us take the transpose of it. Call it third. Call A minus A dash as third and find the transpose of this matrix A minus A dash. So the elements of the first row 0 minus 1 you write in the first column and 1 0 you write in the second column. Take a negative sign common. Take a negative sign common, you get 0, negative 1, 1, 0. That is A minus A dash, I write it again, the transpose of it, we find negative 0, minus 1, 1, 0, and from third, this 0 minus 1, 1, 0 is nothing but A minus A dash. So you find it is negative times A minus A dash. And what is the condition? What is the condition for a matrix to be skew symmetric? That A dash should be equal to negative A. And because here we find A minus A dash whole dash is negative times of itself, so we can conclude that A minus A dash is a skew symmetric matrix. Now question 9, find half the times A plus A dash and half times A minus A dash. You are given a matrix A. Let us first of all work out its transpose by writing the elements of rows in column. So the transpose you get, C A dash you get, write the elements of first row 0 A B in the first column, negative A 0 C in the second column and negative B negative C 0 in the third column. And now given matrix 1 and we have worked out in second its transpose. So what is the value of half times A plus A dash? Keeping half out add the corresponding elements. In the first row, first of all, 0 plus 0, 0, A minus A, 0, B minus B, 0, and similarly, if you add all of them, you will find that every element comes out to be 0. So if you multiply by half, it will remain 0. It will remain 0, 0, each element multiplied by half. So that is a 0 matrix of order 3 by 3. So half A plus A dash is a 0 matrix of order 3 by 3. Now let us work out half A minus A dash. Half times A minus A dash. Half times A minus A dash. Keeping half out, you already have A and A dash. Take the difference of the corresponding elements. You get 0 minus 0, that is 0 in the first row. A minus minus A will make it plus A, so you get 2A, and similarly B minus minus B will make it plus B, 2B, and likewise you find the other elements of A minus A dash. You get minus 2A, 0, 2C, and minus 2B, minus 2C, 0, and multiplying each element by half, you get half A minus A dash equal to 0, A, B, minus A, 0, C, minus B, minus C, 0. So here we have worked out half A minus A dash. Express the following matrices as sum of a symmetric and skew symmetric matrix. You already have a theorem that given is a matrix A, then A can be expressed as half A plus A dash and plus another matrix half A minus A dash. It is very easy to verify algebraically if you take half common, A plus A dash plus A minus A dash, so A dash will cancel, you get 2A into half A. What is important that here if I further denote A equal to P plus Q, and I show, and where what is P? Where P is half A plus A dash and Q is half A minus A dash, and if I show that P is a symmetric matrix and Q is a skew symmetric matrix, then we have done. So that means I want to find out two matrices P and Q, where P is half A plus A dash and Q is half A minus A dash. First let me find out the two matrices A, P and Q, and it has already been observed here algebraically that A can be expressed as P plus Q. And then show that P is symmetric and Q is skew symmetric. That's what is our aim. So let me first of all work out A dash. A, I am calling this given matrix A to 3, 5, 1 minus 1. This is A. Now work out A dash. That is the elements of the first row, 3, 5 you write in the first column, and 1 minus 1 the elements of second row you write in the second column, 1, 1 minus 1. This is A dash. And now work out half times A plus A dash and call it P. So P equal to half A plus A dash. Half as such, you just take the sum of A and A dash, add A and A dash. You get 3 plus 3, 6, 3 plus 3, 6, and 5 plus 1, 6 again, and you get C 1 plus 5, 6 in the second row, and negative 1, you get negative 2. Divide each element by 2, multiplying by half, it is the same thing. So you get 3, 3, 3, negative 1. So that's what we have worked out as P. This is your P. And now here only, let me work out P dash. So P dash, the elements of the first row, write in the first column, that of second row you write in the second column. And from these two, that is the value of P and P dash, what do you find? It's easy to see that P dash is P. So I can conclude that yes, P is symmetric. And now let us work out Q. Q is half A minus A dash. Keeping half out, you already have A minus A and A dash. Take the difference. So it is 3 minus 3 0. 5 minus 1 you get 4. And 1 minus 5 you get negative 4. And 1 minus 1 and minus plus 1, of course you get 0. So this is Q. Now work out the value of Q dash. The value of Q dash, interchanging the row and column. Just wait for a minute. We wanted to get the value of Q as half. So first of all, work out half means multiply each element by half. You get 0, 2, minus 2, 0. So what is the value of Q? It is half the times A minus A dash, which finally we get 0, 2, minus 2, 0. And now let us work out Q dash. So Q dash, the elements of the first row 0, 2 will go in the first column, and that of the second row will go in second column to give you negative 2, 0. Take a negative sign common, you get 0, 2, minus 2, 0, which is nothing but Q itself. So you get negative times Q. This much of it is Q. So what do you conclude? Because Q dash can be expressed minus Q, so we say Q is a skew symmetric matrix. So here we find two matrices P and Q, so that A can be expressed as P and Q, and where P is symmetric matrix and Q is skew symmetric matrix. So finally I should write the given matrix A is, what is the value of P? The value of P is 3, 3, 3 minus 1. And what is the value of Q? The value of Q we worked out 0, 2, minus 2, 0. So finally I conclude that yes, A can be expressed like this, where the first matrix is a symmetric matrix and the second is a skew symmetric matrix. So that's what we have to do.